Here we go.
Welcome, everybody.
So, where do we end off last? Let's do a quick review from last class. Okay, so these are good chips, man.
Yeah.
Don't taste kosher though.
That's really good chips.
Okay, here we go. Variables come in two flavors, right? Primitive. Right? Primitive does what? They actually hold the actual value. Right? So you have a bucket that's a byte or an integer. You make it equal something, it's actually going to be right in there. The cup will actually have the value right inside. Okay? It works like that because it's easy for the memory to know how much to allocate because
That's
it's
not
right
the
there.
remote, right?
Right. That's just primitive right there. There are 8 different primitive types, like we said before. Boolean, car, character, a byte, short, int, long, float, and double.
Be careful, bears shouldn't be large $30.
Right. Now, realistically speaking, these are the ones you'll probably use the most. Boolean, you'll use quite a lot for true or false. Car, you won't use that much. Byte, not so much. Short, not that much. Int, you'll use quite a lot. And then double. So out of the primitives, you'll probably be using 3, and that's about it.
Double, and Boolean.
That's it. The other ones, okay, you can use in circumstances, you know, if you find it necessary.
I never truly got the idea of Boolean. I never got like why you can't just do integer x equals this and if integer
You could do that as well.
equals that.
You could do that as well.
Why do you need like the whole Boolean thing? I never got it.
Why? It's just it's a way to just different. It's different. One time.
Space?
I mean, we're talking about such small amounts of space. It really is not. It's not. The issue is not speed. The issue is really just it's a way of programming that's more common sense. You have a variable, for example. Let's go to here. Let's go to our thing.
Why is string on this?
String is not a primitive. String actually is an object.
By the way, I found the mouse.
Cool. Watch. Let me show you something. Say you have a variable like this. You know, I say it's called has. I don't know. Has head. Okay, does a guy have a head or not? So, like he said, this can be an integer, and you know, 0 will be no, right? And 1 equals yes. But it's much easier for a programmer. Usually, when you see a program, when you're looking at someone's program code, and you see has or
So
contains,
true,
it
Boolean,
usually
yes,
is a Boolean,
Right.
true or false. So that you work with it differently. For example, if this is a Boolean,
Right.
and you want to do an if statement, you would do if, you know, has head. That's it. If it's
has
true or
that
false,
equals true.
then it does it. If not, then it won't do it.
Right.
By this one, you actually have to write out if has head equals 0. So it's more verbose. You have to write more words, and it's less common sense because the way you have this, that usually means you're using a Boolean. That type of variable that has in there contains, right? Yes or no, you want to use Boolean.
So if it does, by Boolean, if it doesn't do it, if it doesn't have head,
Right. Then it won't do as part of that condition.
then it won't write false. It just won't.
So Boolean is
Whatever's after. So you have
Boolean is basically another loop.
well, it's true or false. That's all it is.
What
But
I'm
it can
saying is,
bring in a loop.
You can put it in a loop. Yeah.
if it doesn't have, instead of saying when I'm using Boolean, if I wanted to make it where Boolean has head equals true, what if I wanted to show, well, if it's not true, I want it to show it's false?
Then you said false.
No, but then I want to say if it works out, then it's true. If it doesn't work out, false.
So if
They don't have to
if,
finish
if
it.
I'm not-
doesn't have head or
I'm not sure
basically,
what you mean because if has head already, this contains in it
so
whether
it's
it's true or false.
basically saying how would the CMD understand if it's false or not. So let's say you're saying
If they said it.
Boolean, if it has head then equals true, but then you write down in the code if it doesn't have head then
Well, no, you'll probably get that from somewhere else already. So, for example, say let's give an example like this. Let's give a new screen over here.
So say I want that.
I hear what you
program
mean.
to show up
I hear what
as
you mean.
false.
So this would happen. Say you have, I'll give you a good one. Check this out. We'll have one that's called is alive. Okay. Okay. Now, in the beginning, we're just going to set it. We're going to create it, but not set it. Okay. So it's right now just like this. Okay. Right. We just have an is alive Boolean container. Right. Then we say we have one, you know, where he's, you know, shot or something. Right. Okay. So say he's I don't know, say you can think of another one. Say the rule of the game is like if you shot 3 times, he's dead, right?
Okay.
So say you have a condition, where he was shot 3 times. So you then go, is alive
Equals that.
equals false. In other words, he's not alive. He's dead now.
And what then if is alive equals false? What if is alive equals false? Then
No, you don't. You never do if is alive. You never do if is alive false. If is alive means it's true. If not, then don't do it.
right. But what if I wanted to write after? What if I wanted if it's not alive? Then I want to write that.
Yes. So then you do the else, right? So for example, that's
So Boolean is alive equals true. Else no. That's what I'm
no. So let's give an example. So say without going to we're gonna do pseudocode, not real code, but the idea of it.
Right.
So say you have if
Not
put this in
alive.
parentheses. Let's do is alive. Oops. Is alive, right? Then we do go over here, put the curly brackets, and do I'm not making real code. I'm just making it right. Print alive, right? Right?
saying.
Else, because again, it's not real code. It's just pseudocode. Print dead.
Exactly what I want.
Okay. In other words, the fact that you do this saying if it's true. In fact, you can actually write true. If I want to, I can just write this. For example, you'll
If
see sometimes
true.
loop. You'll see loop sometimes it says while true. And they're just always going to run forever unless you say break and get out of the loop. We had that before in one of the examples.
So to change, could I write the code kind of like this?
Like
If
over here?
it's alive?
Like this.
Yeah.
This is pseudocode. So yeah, the idea here will work. But obviously, you have to get the colons right and etc. and all the
I
print
know,
numbers.
but if I wrote if is alive,
Yeah.
is alive first.
That means if is alive means if is alive is true. That's what it means. That's why the reason why Boolean is better than an integer is because integer, but by accident, a guy can stick in there 3.
Right.
And it doesn't mean anything to the system. It should be 0 or 1. That's it. Only 2 options. So Boolean restricts. You have true or false. That's it. No other options you have.
And it has to be true or false. It can't be unless you're
Right. So it's not set. It's false. Okay. You'll use Boolean. I mean, Boolean won't use it as much. The most out of the primitives, integer and double we use most. Double for all metrics, for like money, and any type of thing that's using
Double is basically another word for money, numeric.
for numeric with decimal points, right?
So why don't we use float? Float is not enough.
Float don't use. Float is a complicated thing. You don't want to. I'm not going to get into it now, but float's really meant for like
Same thing as SQL. We're talking about.
yeah, very similar. It's not. It's used for like scientific applications where we're using huge numbers. You don't really care if it's that.
The way the math is you use huge numbers, but double yet again double more than float.
Right, because double makes. I'm not gonna get the details, but in general, as follows: float cannot guarantee 100% precision, but it's quicker than double. Okay, double means 100% precise. If you have 6 decimal points out and you're adding millions of dollars together, which you have like the stock exchange, they need those millions of a penny because you have million transactions going through. Like a gas station, it's 9/10 of a penny. They need it to be there because they make billions off of that 9/10 of a penny.
Right.
So float is meant for like say you have like they have this collider in Switzerland. It shoots atoms around this like mile track, and they have like they have numbers that go for like pages long, just one number of like what millionth of a second happen. At those things, they don't care about accuracy that much. They just need to be calculating values every single second, millions of them. I mean, and that's why you use float. Float behind. I'm not gonna get behind the scenes, but it has to do with really how computers are not good at decimals because computers use 0 and 1s. Remember, that's all. All the computer knows is 0s and 1s. So it's very hard, in a certain sense, for computers to know how to do decimal points and do fractions because it's not a 0 or 1. Like what's 3/4?
The actual idea of a double is very double or float. They're actually a lot more powerful than.
Then what? Then integers in?
Yeah.
Integers are a simple thing for computers because
Right.
it says 0, 1. You can easily reference a 0 and you can easily write a whole number in bytes.
Right.
But idea of a fraction of a number like 3/4, how do you write that in bytes? There's no thing that you can do. You have 0, 1, and then you have 2, 3, 4, 5.
It's like integer and decimal. Is what you're saying.
Yes. So decimals are not so simple for computers to do. Of course, they do it very fine.
Right, so you straight
But
double.
the logic behind the scenes, how a computer does it. So they make two of them, one for float, that's easier for scientific applications. We don't need 100% precision, and then double for like money. We need to be precise. This is a person's money. You got to be careful with it. Okay? So you'll probably be using integer and double the most. Boolean as well. The other ones probably not so much unless you're, you know, whatever. In applications you'll use it. Okay. We said over here, right? This won't work, even though a byte can hold 24, but it won't work because in principle, an integer is bigger than a byte. And the compiler says, listen, I can't take a chance on
Like
it.
another cup in a cup.
Right, and it's a bigger cup.
Right.
Okay, the opposite you could do. You could stick a byte into an integer because a byte will always fit into an integer.
Right.
Okay, not necessarily should you do this, but the compiler will allow you to do that because it's never going to error out. A byte will always, no matter what, fit into an integer. Okay? Remember that we said you can't use this to name anything because this is part of what the compiler needs is the language itself.
Yeah.
Okay. Remember, so objects, there's no such thing as a variable that holds an object, right? Variable only holds a remote control that points to an object. Okay? Let's go to the picture. So you have this picture, this is an awesome shot.
Okay.
You have, here's the cup where it's holding in it. Inside is a remote control that points to a dog, and then you press debark, it hits the dog to bark. It remote controls to bark. Okay? Okay, so now we're going to go to this picture. Ready?
Yeah, this is right there.
Okay, so here's a picture you have. Don't worry about how we got here. But say we had B is pointing to this one and C go to this one. And then we write, let's go to our ski for a second. Okay, so say we have one and we go like this. You know, so we're using a book here. So say we do book, it's called B. Okay, so book B equals new book. Okay, then let's do book C equals new book.
Or if
So-
you did book C equals old book.
What?
But if you did book C equals old book.
Equals what?
Equals-
Old.
Yeah.
So now, what if I go like this? B equals C.
Now it switches.
Don't switch. B and C. This is why you have to be so careful with object variables.
The reference is moved.
No, let's make this even a little cleaner. So there's-
Whoa.
it works. Watch. So if I go like this, let me actually clean this up because this is actually, you don't even need this over here. I just make book C.
So if you did book B and book C, then book B will be screwed.
Here, so look. Let's do it like this. So we just made. Hey, get out of there, dude. Okay. Here's book C, and we wrote over here. Cross this out. We do C equals B. What is happening behind the scenes right now? Exactly this. C and B, we pointing to the same object. And this is where you be very careful when you're using objects in programming, because if you start changing it from C or B, you're actually touching the same object. It's imagine like me and you writing on the same piece of paper. So you gotta be very careful. With integers, you never have an issue. If I did this with integers, you'd have two different cups holding two different integers. But by objects, you're just giving them remote control, so they can be pointing to the same object.
Right, but here C equals B, it's not the same as B equals C. If it was C equals B, then the C would be pointing to the B one now.
Well, I cross this out. So I cross this out. If I do B equals C, then both will be nothing, because right now B and C has nothing.
Or you say if you did it without new book.
Yeah.
Well, yeah, then they both be pointing to new book.
Well, so right now, let's go through one line.
Let's say book B, you created the new book, that's one. Book C, C equals B, then C now is pointing to new book, the same
Right,
book.
right.
Okay, I get that.
Right. Okay, so let's do a different example. What if I did like this? Integer. You know, x equals 1, and then integer y, and then y equals x. They don't point to the same integer. They have, y has its own cup with 1 in it, and x has its own cup with 1 in it. So if I change x, it doesn't change y. Change y, it doesn't change x. They're two different ones. It makes a copy of it.
Well, if you change X, then the Y is not automatically changing because it's the way it's written.
Not if I do it, change it afterwards, because then it makes a copy.
Oh, if I change it afterwards,
Then it doesn't change it anymore. Look, if I go over here under this now and go, here, let me put this little down. If I go over here now and I do x equals 1 plus 1. So now x equal 2, but y stays 1.
Okay.
Because at this point, it made a copy of it.
Right, okay, that makes sense.
But over here, they actually point to the same object. You can never, when you have things for the same object, you be careful. Because if I now change the name from B and then change it over to C, they overwrite each other. Whichever one runs last will overwrite. Okay? Now, in general, you'll see in code, this usually not going to be an issue because you're not going to be changing variables with other object variables. But just keep that in mind, that with an object reference, when you do a copy, you're just giving another remote control. So like two guys handing a remote to the TV, they can just start pressing channels and they're knocking each other out.
But it says, I read this already and I got a little confused, but it says it gets worse and worse.
Gets worse and worse?
It's saying how it can get worse and really the next one.
Okay, so now let's go, for example, let's just do a quick one. Say, okay, so say over here, we first made C equal its own book. Okay? Okay? So, just do up to here. So you have 1B and 1C.
Right.
So they're pointing to two different ones.
Right.
Then do C equals B. So what happens to the old object?
Nothing, the caca.
Right. So that object that used to be pointing over here is sitting in memory, but there's no remote controlling it. And that's when the garbage collector goes by and goes, whoop, knocks it out.
Really? Actually knocks it out?
That's it.
Can I get back it?
Can't get it back. Too late. Because now there's no remote to it. So no one can ever find it anyway. So it's just wasting memory.
And you can't go back and redo it?
You can't find it. It's not. It's gone.
You have to make a new one.
Yeah. That's why it's very important to have a database so you can save things.
But I always thought when like SD cards and all stuff, you save it and then you delete it and then
In time?
you still get it.
So saving, what does saving mean? Saving means you're writing it to some file or a database.
And then you delete it.
Then you're just getting out of memory. But once you load it back in the database, you're putting it back into memory.
No, if I take an SD card,
A what?
an SD card,
SD card.
my camera,
Right. That actually has
I delete my pictures.
right.
I went and I put a program down and it brought all the pictures up.
Okay, so you're actually talking about something else because what happens that's the difference.
Okay.
By a disk, any type of disk, whether it's an SD card or it's your hard drive on your computer, when you delete a file, all you're deleting is the pointer to the file. With the file,
You're pointing. You're
but it's different than this
remote.
because this is a memory that's on the disk. It's no difference. Memory gets wiped, it's gone.
Oh, right, because this is not in a hard drive. Right?
This is in memory. On a file disk, if you delete a file, you're not really deleting the file, you're deleting the pointer to the file, and that's why you can get it back.
Because I always thought the objects were
Objects are
hard drive,
never
and
right.
Those were remotes.
Right. So objects are never in the hard drive. Impossible. Objects by definition mean they're in memory. You can load it from the hard drive into memory and then play around with it and put it back into the hard drive or to your database. But an object is never in a hard drive. It's impossible. You can call it that. You can say that we stored it in the database. Like even object
Every time we press save, it stores in the database, and then the next morning we come up. Where's the object now?
For example, look right now. You see this over here? This application I'm using. If I go now like this, watch this. Okay, and I press save yet. Right now, all my changes are in memory.
Right.
So if I wipe it out, it's gone.
Right. So here.
If I press save, boom, it writes to the database, and when I open the application again, it brings everything back into memory.
Right. So I was saying it's the objects at night when you save it, it goes into memory.
It goes now.
Internal actually
Right.
to the hard drive. And in the morning when you get cut. So now once you press C equals D, and you didn't save it, then it's
Right.
go back to the same thing.
Right.
But if you save this, well, you just did right now. If you
Right,
save that,
and then load it back
it's gone.
again. Yeah. Okay. So in other words, memory is not like a hard disk. By memory, if you remove a pointer to it, if you say, I'm not using this anymore, it's gone. Because memory, you don't have that much memory. Memory your computer needs that very much. Okay, let's continue. Okay. Okay, so what if we're over here? Okay, so now let's look. We have C and B pointing to the same one, right? Who's still with me?
Oops, to the right.
Yeah, let's just do a new one.
Do the black.
Okay, so we have B and C pointing to the same object. What if I go like this? C equals null.
That's C, you're pointing with the object.
Wait, you said B equals C to begin with?
Right, so B and
And
C
then
point.
C equals none. Null.
Right, right.
Then
basically
B
C.
equals null as well.
What time?
No. So
B equals, if C equals null
So that's
and B
the
equals
difference.
C,
No,
So yeah, that's the only difference. So C equals null doesn't mean that you're removing the object. It means that the variable out, the
It's
remote
just
control
zero.
doesn't point anywhere.
Yeah.
So what will happen is
B is
this
still there.
picture. Right.
Yeah.
So B still points to it.
But
Okay, so that's the difference. If I were to go and do C dot name, forget this, I didn't write this yet. Do C dot name equals,
Jeffrey.
B. Then if I do get the B dot name, it'll also equal B. But C equals null means I'm taking the remote control and removing it from any TV.
But I can always bring that back since it's there.
If I go back to C and copy from B. But if I take B away, now that's in garbage collection.
Right. So when I'm done now, so let's say I write the scenario you just wrote. Then right after you finish that, at the end, right after that, I wrote C equals B again.
Then you get it back. But if I do B equals null, then no one's pointing to it, and again, it's all gone.
What are you using after you do C equals null?
Yeah, so I do B null and C null, then both these objects are toast.
Right, yeah.
Okay?
And what do I do with those? They're just sitting remotes?
What? Yeah, there's modes not pointing anything. I can point it again to something else. I can make a new dog and point, a new book, whatever it is.
Well, that's because it holds that object, and that's it.
It points to that one,
It
yeah.
points to one object.
At one time, I can change it like I did B equals C, C equals B. Right.
And then there's some arrays, right?
Okay, so a remote control, you can point to many different objects, but not at one time. Okay? Okay, so now we're done with that basic concept. Now we're going to get into the arrays. Okay?
What?
Now we'll get into arrays. First we'll do primitive arrays that hold primitives, and arrays that hold objects, references. Okay, so let's look at this picture over here. Okay, so an array is like a tray of cups. Note arrays are objects too. The array itself is an object. But what it holds cups that hold whatever it is. It can be integers or it can be objects, references, right? So here we go. Int nums means you're creating an array that holds integers. Okay? We didn't say what's in there yet. Now we can go over here and we want to hold 7 spots, 7 cups for integers. So you'd have over here 7 different cups. Okay? And this is how you would set them. Num cup 1. In other words, the cup 1 in my tray of cups, make it equal 6, make it equal 19, make it equal 44. Right? So in here, you would have inside here 6, 19, 44, 42, 10, etc. Right? So with an array is always an object itself, is always an object, and that's why you can call array.length and find out how many things are in there. Right? It's an object, and treat it like an object. But what it holds for each slot in the tray, it holds a cup, which you can put inside an object, or you can put it in a primitive. Cool?
I could do string the same thing, string those.
100%. Okay? So notice that the array itself is an object, even though the 7 elements are primitives. So this itself, this nums, right, this whole thing that we call nums, which is an array, is an object, but all the individual spots are primitives.
And so the int is basically pointing to that object.
So each of these ones are integer primitive variables, but the thing itself is an array that's holding that, which is always an object.
So what if I did that with strings? I could do tens and dogs.
Yeah. So look at that as the next example. Here you go.
Yeah.
Okay. So let's look at this one. Here's dogs, pets. So at this point, we just made the idea that we're going to make a whole tray.
This is an array.
Yeah. So this also is an array.
You just use the word nums. Nums doesn't mean anything, but
That's just the name of the variable.
I can do integer anything I want. Right?
Yeah. Okay. So here's dog. We're calling it pets. At this point of it, all it knows that you're making an array. It doesn't know how long it is yet. If it's going to hold 5 dogs, 3 dogs, or 2 dogs. This next step says I'm holding 7 dogs.
Why is there a space in this one not space here? Just accident or?
Yeah.
Can you make it in one line, like dog? Or
Yeah, you could. If I'm doing this, you can understand what each step does. At this stage, all you are saying, I'm making an array object of pets. And it's obviously only going to hold dogs. This defines what it's going to hold. Okay? And over here I'm saying I'm going to put 7 dogs in this thing. And this is how you'd set it. Okay? Pet 0, this thing, has this dog, another dog. And remember, over here is where it's cool. So you have a dog array object that's holding cups, and the cups are holding remotes that are pointing to objects. Okay, just look at this picture for a couple seconds to let that sink in.
I get what you're saying, but how are you going to report
Each cup points to a different dog object.
Each cup holds a remote that can point to an object.
Oh, so now
But they're all different objects.
Not necessarily. I can make two cups have remotes that point to the same object, just like I had before. They hold
The
remotes.
dogs, because over here from this example, it says that pets, which equals dog. You have 7. You have 7 parts of that array,
Right.
and then each remote points to a different thing.
Because they're not necessarily
Right. And this example does. If I want, I can do pets 1 equals pets 0, and then these two would point to this one.
Instead of equaling new dog, it
Right.
equals, okay.
Now do pets dot something.
Yeah.
Pets 1 dot something.
Here you go. This is how you actually use it. So pet 0 that name equals Fido, and pet 0 that I can make it bark.
And why would we do this?
Why would you?
To keep it more organized.
I mean, that you could do this. If you want, you could do this with another. This is easy. You don't have to name the variable. That you just pick out the. Say here's an example. So you have.
It's like easy. I said dog.
Right. So say you have you have a code that puts dogs in a line. Right? Any dog can come in this line. As the dogs walk by the vet gives them a shot. So, Ray, number 0, pet 0, shot. Pet 0, 2, shot. And you can just go through the whole loop without giving each one a name. You don't have to know the name of the dog or anything. Shot, 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 shot. That's it.
So I can use this. Oh, I see.
In other words, over here, pets 0, right, which is the first one, we're naming this object Fido, the name, and we tell it to bark. But I don't even know at this point. It's just all I know is pet 0.
Right. So if I wanted to, I can add pet 0 and I can add all the information, and it will still point on 0. So if I wanted to, if I was doing it like they talk about, well, customer 534 said X, Y, and Z.
Right.
So if I wanted to, I can make one of these things that are 1,000.
Yeah.
And pet, number him, and let's say all these customers come in and you keep track of customers like they do in places. And if, let's say, someone signs up as a sheet, you just stick their name to that thing. So now
Perfect.
that person is this person.
Yeah, like you ever go to like the DMV and you give like a number in line.
Exactly.
Number 52, right? It's the exact thing. You're in an array and that's it.
Wow.
Okay, so the cool thing over here, so I can know what's going on. We have a dog array. So you have one object itself that's holding all these cups.
So it's giving you the ability that you don't have to write 1,000 different classes.
Right. So right now this might sound confusing, and it's very theoretical. But later on, when you're debugging code, you'll understand sometimes why things are not working. For example, you recognize it'll have. For example, I can go over here. Look at this example over here, right? If I wanted to, I can go under and do. I can go like this. Pets 4, which would be this part, which is not putting anything yet, equals pets 0. Oops. Right? And then this one will point to this one. They're pointing to the same object. And each one I can change overwriting again. In other words, the flexibility that you have.
But how for debugging that would help you because
Then you know what. You say you didn't realize what you did, and you're wondering, wow, how's this thing even overwritten? You understand? Oh, okay, these are just remote controls. And even though they're sitting in this dog array, they're pointing to the same one. And just to know how these things work. But at the end of the day, when you're a programmer, you spend more time developing stuff. But when you hit a debugging situation, we have an issue. What's going on here? Unless you know how this works behind the scenes, you're going to be lost. And that's this what makes a good programmer a beginner. This book did not even have to teach you this. I've seen courses on Java that don't even teach any of this stuff. But what happens is when you don't know what to do, you have to go to the senior manager
this book teach you?
This book teaches you everything to be your own developer. After this, you can make your own code, and you're self-sufficient. You don't have to go to the lead developer in your group and say, debug my code, something's not working, I don't know what's going on. You can go, oh, I know what's going on here. I have 2 parts of the dog array pointing to the same object. And that's why they're overriding each other. Or, I'm trying to put a cat in
so
this.
what was the situation that I would see as they're overriding each other? How would I see it?
Say you have some code and 2 parts of your program are, you don't realize it could be 1,000 lines long, and somewhere by accident you wrote the same code that's using this same array, and it's somehow accidentally in your code
It's erroring out.
Or you get the wrong information.
Okay.
You have one guy typing his information, another guy his information, and they're overwriting each other, or the codes are overwriting each other. You know what I mean? Okay.
Honestly, the more I'm learning Java, the more logical I'm seeing it.
Yeah, I mean, right now the good thing is that we're getting all the. I mean, this book is a tough book because it really goes in depth. It's an amazing book, but you give me a good programmer.
Paying you something?
Can you?
Give me one or something?
Who?
Who?
I'm paying my right. They're paying me off to look online.
2,500 a class.
How much reviews this book got? It's the best book I've ever seen on programming in general, not just Java. This one specifically. There's more head first books they have. Okay. But remember, the array itself is always an object. Okay, so for example, I can always go, say this array was called pets, right? I can always do pets.length, right? Which will give me back 7. 1, 2, 3, 4, 5, 6.
I'll actually tell you how many.
Yeah.
Right? And
That'd
even
be
over
kinda
here,
funny, right?
we had that before, and even over here, even though this is holding primitives,
Let's still tell you.
the nums itself, I can do nums.length, because nums itself is its own object.
Right, right.
Okay? Okay? Let's move down a little bit. Okay, just I did it. There's different types of data storage things in memory, right? When we start the database, we have tables and, tables. That's basically it, but you can utilize it in very powerful ways. When you load stuff into memory, an array is one way of having data stored in a sequence, an easy way to get. Later on, we'll learn different things like maps and trees and sets, but don't worry about that right now. Okay?
Okay.
Arrays are very powerful, and most of the stuff you're going to get fit with that. Okay, last more important point, which I bet you got already, is that once you declare an array, you can't put anything in it except the declare array type. So this says dog, right? You can't put in a cat, and then you can't put an integer in there because it's totally dogs. However, just like before, we can put a byte into an integer. You can do that over here as well.
Okay.
That's it. That's chapter 3, guys.
And
I actually like this chapter.
It's very cool. You get really to see how behind the scenes how programs work. And Java did a very good job of, in general, how they. Other programming languages make it a lot more complicated. This is one thing where even though Python you write simpler, behind the scenes this does it a lot simpler to understand how it's working a lot more simpler. Yeah, you said something, no?
no, on the book, something on the book and does it.
Okay, so let's just go through this code example, then we'll go through that. Okay, so here's a quick example. Okay.
Yeah, this question. Yeah, exactly what I want to ask you.
Yeah. This code's.
Yeah.
Okay, so let's go through it. So we have a class called dog. Okay. String, what the name is, and it barks. And all it does when it barks is it says the name, says rough.
The public void part, where it brings the bar and where? No.
It's the method.
This is a method.
Oh, okay.
We're naming it bark. You can name it whatever you want. You can name it Kanuchi if you want.
And the dog.
What?
For the verb. Which dog?
What are you talking about? What dog are we really?
The dog. Dog one.
Over here?
The dog. Yeah, which
Pointing to
dog?
itself.
Oh, you're not doing the testing thing here?
You should. This is just the way it was in the book, so I'm just doing the book.
This is why I'm.
Yeah.
Yeah.
You
I
should.
understand.
You should have
So you
another.
told us before that
Yeah,
we should,
you definitely
we should
should.
specifically make it
So we should.
dog and then
100%. Another class to
Dave,
test the class.
just
Yeah.
Dave
This is
and
very.
In OO, pretty much do the array, and then in the other class you would put down.
Yeah. So this is not good. This is just showing one
no
point.
pointer. There's no remote.
Right. I mean, we are creating remotes to this dog, but this tester class should be a separate thing. This whole method should be in a totally different way. But you're still making. When I'm going over here and I do dog one equals dog, it's
Yeah,
creating.
it's working, but.
Yeah.
Yeah, good. That's it.
Okay, so what's happening? Let's go through this code. Let's run it first and see what happens. Okay, so if I run it, CLS clears the
Yeah,
screen.
it's so cool. With CLS.
Yeah, much easier. Okay. Okay, so first it says Bart says rough. It goes through this main, right? This
No,
is
it's supposed to say null.
in time. I did a little different in the books. Don't worry about
Oh, okay. So that, what do you do?
it. Okay, so let's go through it. Ready? We have. Let's look at this one. The rest are really invalid. This are just eat and chase captain. We haven't defined what they do yet. So I mean, they don't do anything.
But they
Right.
can just sit there if you want.
Right? They're like it's like placeholders. In other words, we haven't decided what eat will do yet, but we made a method that later on we can fill in. So look over here. So at this point, dog1 equals this. So we made this object reference.
Right.
It looks at this class, and we're
You know
pointing
this is
to
the object.
right. So name it Bart and Bark, right? So at this point, it spits out itself. Bart says rough,
So it's basically,
which is why the first line says
one
Bart.
down.
I can hear you.
You point the bar. Okay.
Yeah, there's no order. I can put this thing over here and it'll still work. There's no when you're making
No
it.
order.
There's in here within this is an order because this is within the method itself.
Anything
But
in the
how?
bracket.
Yeah. So how if I put this, I can take this whole code and put it under here and it'll still work. There's no order in the methods, but
There's
in the
not a
method
sequence.
itself.
It's not like SQL order.
Right. But however, over here it is. Like for example, this goes in order. Once I'm in the method, from here to here goes line by line.
Right.
But this whole thing itself, this whole method, I can put under here.
Basically, the actual brackets, it doesn't matter. Anything that's in the brackets doesn't matter where you put if, what, where, except for as long as it's in the bracket, like a while thing. Everything within that bracket has to be in order, but everything else doesn't.
No, I take it back. No, everything has to be in order except for the instant variables and the methods. Everything else has to be in order. Everything in here has to be in order. For
No,
example,
that's what I said. I'm agreeing with you. Anything in brackets.
but this is a bracket too. So
No, I'm saying
this over
like
here is a
wild
bracket.
or a public static name. You're doing all that in brackets. That bracket, and after that bracket comes the public void bar.
Okay, but this bracket I can't move to somewhere else. It won't make sense.
Right.
So it's just the instant variables and the methods you can arrange any way you want. But once you're inside a method, everything goes. It just runs in sequence. Okay, so look, so to make a new dog, call it Bart and Bark. So at this point, it's going to spit out Bart says rough, which is why the first line says Bart says rough.
Yeah. How again?
It goes to so we're running through here, right? Goes to line 1, makes a new dog, names it Bart, and calls Bark.
Okay.
Bark itself will then spit out that says Bart says rough, which way I have the first line says Bart says rough. Then it continues and makes an array of dogs, which has 3 parts of the array, 3 indexes, 3
So what
parts.
is changed in the book? What is the difference between what you did in the book?
I don't know what's in the book, so let's go through this one. And you'll look through the book. I have no idea. So dog 1, which is 0. I hate that. That's one thing I hate about programming.
Yeah.
It's all languages do this. I don't know why they do it. But dog 1, which is 0, equals new dog. Dog 2 is new dog. Dog 3 is this one. So what's happening now?
So
You're
it's
putting
gonna be
another remote.
Bart
Here we
says-
go.
Yeah.
So it's
It's
another
like
remote.
an A and a B. It's 2 remotes basically.
Right. So I wouldn't have to name it because it's named already. Right. So I named 1 and 2, but dog 3 already has his name because we're just pointing to the same thing, which is why when I go over here and do the last dog name is and put the last dog name was already set over here. And that's why it says last dog name is Bart.
Go back again. Last dog name is system out. Last dog name Y.
See over here? My dog 2
Oh, I see.
equals dog 1, which was
No, but it said system print out. Okay, last dog name is system print out.
just put in 2 lines. Whatever. I can put in 1 line if you want, but that's just
I know, but what? So first it just prints out that, and then the next thing it's going to print out is
right.
whatever. the name
So
of
is
the
Bart.
dog
Okay. Okay. But the cool thing over here is you see how there was 2 remote controls pointing to the same dog. Right. This dog 1 is pointing to Bart, and this my dogs 2 is pointing to
is.
the
Then
Bart.
why is the line? Why is it still the same line?
You hear?
Why is it still the same line?
The way print line works is that afterwards it makes the next line. So the next statement will go to the next line.
If the system out print is technically one statement.
This is one statement, and then
Yeah.
this one goes in the same line, but then puts the next
Next
statement.
one.
Yeah, we'll go to the next line.
Oh, so put print line means the statement.
Yeah,
Yes,
and it ends the line, so the next statement will go in the next line.
Right.
Okay, so that's what we have the first 2. So we have Bart says rough, and last dog name is Bart, and now we have 2 things pointing to Bart.
Right. It says Bart says rough twice.
So later on, when you loop through it, again, now we're going to loop through all the things in the array, loop through it. So as long as x is less than the amount that's in this array, take each dog and bark. So it's going to go through. Fred barks, Marge barks, and then Bart barks.
That's weird. That's not a good program.
I mean, the code makes no sense, but it's just showing you, number 1, how you can loop through an array. It's showing you how you can have 2 objects with 2 object reference variables pointing to the same object. That's all it's trying to show. So one thing to note over here is that you see over here how I can do my dog 0. This doesn't have to be 0 or 1. It can be a variable, if you see over here. as we loop through it, keeps on sequencing 0, 1, 2, 3. 0, 1, 2. Right, whatever you put in here that's the number it takes out. Cool.
With x, which x equals 0 is the number equals 0.
Right, and then next one equals 1 equals 2. Cool. Any questions, Habibis?
Yes.
Go ahead.
So explain me how I show you in the first open the assembly. How it show you Bart in the first one because mine show no.
No, because your code probably has it like this. Probably barks first and then says its name. At this point, it has no name, so name is null. Okay, that's.
How do you figure out?
Okay,
Play around with it.
that's probably the difference. Coolio?
Cool.
Let's save it.
Cool. Guys, we're done with chapter 3. So tomorrow we'll do a review. Bring any questions. There's no questions. We're just going on chapter 4.
Why? So
I have to, I'm gonna take up class for sure and just,
One more time?